Okay, so today we're going to look at the introduction to organic chemistry. We're just going to be looking at naming of organic compounds using the Iupac system. Okay, so these are just some sample questions that we've picked out that will help us to add the rules for naming organic compounds given their structures like that. So the first question, the question is saying, give the IUPAC name for each of the following. So they've given us this entire structure, this side, as for the first part of the question. So now, according to the IUPAC system for naming organic compounds, rule number one states that you need to identify the parent chain. You need to identify the parent chain in the organic compound. So the parent chain is one that is having the highest number of carbons in the compound. So we have two parts of the compound. We have this chain structure. The chain structure of an organic of a hydrocarbon forms the aliphatic chain, and then we also have this ring structure that consists of 6 carbons. So 6 carbons with 3 double bonds inside. This ring structure is an aromatic structure that forms benzene. Okay, so we need to determine whether the benzene ring is actually the parent chain or this aliphatic chain this side is the parent chain. So in order to identify the longest chain, we count the number of carbons in the particular organic compound. So counting the number of carbons from left to right, this gives us carbon number 1. So this gives us carbon number 1. This is carbon number 1. This is going to be carbon number 2, where the benzene ring is attached. This is going to be carbon number 3, 4, 5, 6, 7, 8, 9, 10, 11. We have a total number of 12 carbons in this aliphatic chain. The benzene ring, it only consists of 1, 2, 3, 4, 5, and also 6 carbons. So now, because the aliphatic chain is one that is containing the highest number of carbons, therefore it becomes the parent chain. So meaning that the parent chain, since it's having the 12 carbons, it becomes the prefix to indicate the parent chain, it becomes dodec. So the prefix, if an organic compound is having 12 carbons, the prefix is called dodec. If an organic compound is having 10 carbons, we just know to say it's dec. But for an organic compound that is having, let's say, for example, 13 carbons, so these are 12 carbons, it becomes dodec. If it's 13 carbons, you just add tri to dec means 10 carbons. And then when we put DO to dodec, to dec, it becomes 12 carbons. So when we put tri to dec, it indicates to say an organic compound has 13 carbons. So it becomes tridec like that. So for coming back to our structure is having 12, the longest chain is having 12 carbons. So the prefix to indicate 12 carbons becomes dodec. So we check for the presence of any double or triple bonds in the longest chain or in the parent chain. So now, because we do not have any double or triple bonds in the parent chain, therefore the suffix, meaning the name ending for this particular organic compound, is going to end in ANE. So this suffix ANE, it only indicates to say this particular organic compound belongs to a homologous series of alkenes. Okay, so the name ending for alkenes becomes ANE. So we've identified the parent name is supposed to be dodecane, like that. So now, since at carbon number 2, at this carbon number 2, there is a benzene ring that is coming off as a substituency. So when a benzene ring is coming off as a substituency, it's called, so when benzene is a substituency, it's called phenyl. So when benzene is a substituency, it's called phenyl. So now, at which carbon is the phenyl substituency located? It's located at carbon number 2. So we number the location of the substituency in such a way that it's going to give us the lowest number for the location of the substituency. So the smallest number for the location of the substituency becomes number 2. So at carbon number 2, there's a substituency phenyl that is attached, and then the entire compound, the parent name is dodecane. Therefore, to complete the name for this particular compound, it becomes 2-phenyl dodecane. Okay, so that's it for the first part of the question for Roman numeral 1. So the name for this particular organic compound, it just becomes 2-phenyl dodecane. Okay, so that pushes us to the next question. The next question is, it has given us this entire structure. So now, to identify or to name the particular organic compound, as usual, rule number 1, we identify the longest chain. The longest chain is one that is having the highest number of carbons. So counting from left to right, this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4. So since from left to right, there are 4 carbons, therefore the parent 4 carbons indicates the prefix of bute. So the bute only indicates to say the compound consists of 4 carbons. So now, since the compound consists of 4 carbons, it becomes a bute. Step number 2, we check for the presence of any double or triple bonds. So now, if you've noticed, at carbon number 1, there is a double bond. Carbon number 2, we do not have a double bond. Carbon number 3, there is a double bond. So at carbon number 1, there's a double bond, and also at carbon number 3, there's a double bond for this particular organic compound. So if an organic compound has a double bond, the suffix or the name ending for the organic compound is supposed to be ene, only to indicate to say the organic compound belongs to a family of homologous series called alkenes. Okay, so since it's an alkene, the name ending is supposed to end in ene to indicate to say there's a double bond, in the organic compound. Now, since you have 2 double bonds, if we just ended the name as a butene like that, it would indicate to say you only have 1 double bond in the organic compound. Since you have 2 double bonds in the organic compound, you add the prefix di to ene so that it becomes diene, to indicate to say di means 2, and then ene just indicates to say there's a double bond. So this becomes diene. So the name for this compound, at carbon number 1, there's a double bond, and also at carbon number 3, there's a double bond. Bute indicates to say the longest chain has 4 carbons. Di, ene, to indicate to say there are 2 double bonds are present in this compound. Or alternatively, you can name this compound in this other way. So we've identified to say the parent chain is having 4 carbons, so it becomes a bute. And then at carbon number 1, there is a double bond. At carbon number 3, there is also a double bond. So bute 1,3 diene. This is an alternative way you can name this particular organic compound. So this only indicates to say at carbon number 1 and carbon number 3, there are 2 double bonds altogether in the molecule. That pushes us to the last part of the question. So this last part of the question only shows this particular compound. Okay, so to name this particular compound, we first identify the longest chain. So the longest chain is one that has the highest number of carbon bonds in the hydrocarbon chain. So if we're to number these carbons, we can number them. Numbering can start from left to right or from right to left. So however way we're going to number this carbon, we are going to find out to say the longest chain is going to have, this is carbon number 1. At this joint is carbon number 2. This is going to be carbon number 3. And this could be our carbon number 4. This could also be our carbon number 4. So let's just number this as carbon number 4. Now, at carbon number 2, there is this substituency that is attached at carbon number 2. And then at carbon number 3, there is also a substituency that is attached. So the CH3 substituency, it's called methyl. So when a methyl group is occurring as a substituency, it's called methyl. So altogether, we have 2 methyl groups that are attached at carbon number 2 and also at carbon number 3. So to name this compound, it becomes, let me just clear out this part so that I can have some space. So naming compound number 3, the name is now going to become, at carbon number 2 and also at carbon number 3, there are 2 methyls that there are methyl groups that are attached. So now, since the total number of the methyl groups that are attached, we have 2 of them. You add the prefix di to the substituency to indicate to say you have 2 of them that are attached in the compound. So this becomes dimethyl. And then the parent chain, we've identified to say it has 4 carbons. So this becomes bute for the number of carbons. And then for the presence of the any double or triple bonds, since we do not have any double or triple bonds, the suffix name for the parent name is going to end in A and E, just to indicate to say it belongs to a homologous series of alkenes. So now there you have it. That becomes the name for this particular compound, 2,3 dimethyl butane. So now we'll be on to the next part of the question. Okay, so welcome back to our second part of naming organic compounds. Okay, so these are sample questions or sample compounds. So give the Iupac name for each of the following. We still are going to apply the same rules for naming the organic compounds. So since the first organic compound, according to rule number 1, we identify the parent or the root chain. The root chain is one that is having the highest number of carbons. So we number the carbons. We can number them however we want, from left to right or from right to left. So going from left to right, this is carbon number 1. This is number 2, 3, 4, 5. This is 6. This gives us 7 carbons. Just for the sake of counter checking, you check if any substituencies are coming off the parent chain, for which we do not have any substituencies according to this compound given. We check for the presence of any double or triple bond. We do not have any double or triple bonds in this particular organic compound. So that only indicates to say the suffix name or the name ending of this entire compound is going to be A and E, to indicate to say it belongs to a family of homologous series called alkenes. Okay, so let's identify. So the total number of carbons that we do have in this, it's 7. So the prefix to indicate 7 carbons, the prefix is hept. Then after the prefix, you add the suffix to indicate the homologous series to which this entire compound belongs. So the homologous series is A, That's the name ending for the alkenes. This entire compound now becomes heptane. So this is the name for a 7 carbon hydrocarbon. Okay, so let's check out. So the first one, the name is just heptane. So hept, to indicate there are 7 carbons, Ane, a suffix for homologous series of alkenes. Let's move on to the next compound. So the next compound only shows, so the next compound we identify the longest chain as usual. The longest chain is one that is having the longest or the highest number of carbons. So we can count either from this direction or this other direction like that. So from left going back to, from right going back to left, this is going to be carbon number 1. Where the chloro is attached, this is going to be carbon number 2. This is going to be carbon number 3, number 4, and this is going to be number 5. This is carbon number 6. Where the methyl and the chloro are attached, this is going to be number 7, number 8. Where the chloro is attached also, this gives us carbon number 9, and this gives us a total of up to 10 carbons. So the longest chain has a total number of 10 carbons. So it indicates to say 10 carbons, the prefix becomes dec, to say the compound has 10 carbons. Okay, for this one, I will need some lots of space. So we'll say dec to indicate to say the homologous series or the organic compound has 10 carbons. So we check for the presence of any double or triple bonds. So we do not have any double bonds throughout this organic compound. Therefore, its name ending is going to be Ane. So the parent chain or the parent name is going to be decane. Now, in this parent chain, we check for the presence of substituencies. So the substituencies are those groups that are coming off the parent chain. So the groups that are coming off the parent chain is, if you identify at carbon number 2, there is a chloro that is attached. Also at carbon number 4, there is a bromo, and this group which is attached, a methyl group. And at carbon number 7, there is a chloro and a methyl group that is attached. So when a bromine atom is a substituency, it becomes a bromo. When a chlorine atom is a substituency, it becomes a chloro. So even at carbon number 9. So in naming of substituencies, so the name of substituency, to name substituencies, we follow alphabetical order. So now, in total, you have a bromo, a chloro, and only a methyl. So there are only 3 different types of substituencies that are attached. We have a bromo that is attached. We have a chloro. We also have a methyl that is attached. So naming or numbering of substituencies, we follow the alphabetical order in which that indicates the attachment of these substituencies. So naming them alphabetically, a bromo comes before chloro, which comes before a methyl. So we identify the location or the numbering for the attachment of a bromo. So the numbering for the attachment of the bromo is attached at carbon number 4. So this entire compound, this compound is going to become 4 bromo. So it's going to become 4 bromo. Then after bromo comes chloro before methyl. So at carbon number 2, there is a methyl. At carbon number 7, there is also a methyl. So 2, there is a chloro. 7, there is also a chloro. And 9, there is a chloro. So at carbon number 2 and at carbon number 7 and also at carbon number 9, there are chlorine atoms that are attached. So now, in total, we have 3 chlorine atoms, 3 chloros that are attached. So since we have 3 chloros that are attached at 2, 7, and 9, you add the prefix tri to the chloro so that you indicate to say we have a total number of 3 chloros that are attached at 2, 7, and 9. So this becomes trichloro. So trichloro, the parent name keeping in mind to say it's decane. So trichloro, we still have one more substituency that we haven't mentioned or listed. So this substituency is a methyl substituency, which is at carbon number 4. So at carbon number 4, we have a methyl. At carbon number 7, we still have a methyl. So in total, you have 2 methyls. Therefore, it becomes 4, 7. Since we have 2 methyls, so it becomes dimethyl. Now you bring in the parent chain. The parent name we'd already established to say it becomes decane. So there you have it for the name for this compound number 2. So the name becomes 4-bromo. So 4-bromo, 2, 7, 9, they are chlorine atoms. So 2, 7, 9, trichloro, 4, 7, dimethyl, then the parent name is decane. Down to the last organic compound. Okay, so down to the last organic compound. The organic compound that we have a benzene ring that is merged or rather fused with a butane or a cyclobutane. So a benzene ring, a benzene is just an aromatic compound containing 6 carbons with 3 double bonds inside. Okay, so according to the rules for naming these organic compounds, we need to identify the parent name. The parent name is one that is having the highest number of carbons. So since we have 2 rings that are fused, the benzene has 6 carbons altogether, and then the cyclobutane only has 4 carbons. So the total number of carbons we only have, the total number of the parent name is going to have 6 carbons. So since the parent name is benzene, which is having 6 carbons, so you write your parent name, which is benzene, having 6 carbons. Then, since the cyclobutane is fused with a benzene ring, when an aromatic compound is fused with another ring structure, the substituency changes. Instead of having cyclobutyl, so instead of having cyclobutyl, you now are going to have, because the cyclobutane is fused with a benzene ring, the compound is now, the substituency is now going to be called cyclobutarbenzene. So cyclobuta, meaning the substituency that is fused with the parent ring, and then the parent ring we've already identified to say it's benzene. So this name, or the name for this compound, is now going to become cyclobutarbenzene. Okay, so that's it for the second part of naming organic compounds. Thank you very much.